I'm Keith, sometimes called Kevin. Those who know me know the joke. I don't like speaking too much, but I do, like many other speakers here, like teaching other people. I like being a part of seeing the spark of learning enter into the eyes of those who are seeking to improve themselves. And so hopefully there's something new for you here. If not, lean over to your neighbor who isn't, who's still learning some of this stuff. And here, I'm here to talk about JSON web tokens. Who here has heard of a JSON web token? Who's used JSON web tokens, verified, signed? JSON web tokens. No, we're short on time, so we're going to keep going. JSON web tokens, by the definition, a compact URL-safe means of representing claims to be transferred between two parties. Just a fancy way of saying, I need to send someone data, and they need to verify that it was from me. Sometimes that token gets transferred between multiple parties, and they need to make sure that it came from me. Thanks for coming to my TED Talk. No. No. Okay, this is a JSON web token. It's really just a big string. I'm going to zoom this in a little bit. And it's got three main parts. A header, which is meta information about the payload, or about the token. The payload, the middle section here. And the signature. That's the thing that actually verifies that the header and the payload have not changed. So this token could be used. One thing to note about JSON web tokens, if you're not familiar, at least the non-encrypted version of them, this is encoded. There's nothing secret in here. If you give this token to someone, they could easily decode this. This is just base 64 encoded data, not secret. So rule number one, don't put anything secret in there that you don't want other people to know about. Okay, so more information about the header. So the header contains the algorithm that's used to sign the data to make sure that it stays the same. It's self-describing. The payload is the actual raw stuff that's in there. There are some registered claims. You can read those there. Those are standard claims that are used in a lot of different specs. None of them are required. You can put whatever you want in there as long as it's JSON. And then the signature is the thing that is actually the cryptographic piece that makes them secure. This is a very naive implementation of signing a token. It's just a function, takes in a payload and a secret. This is hard-coded to use the HS256 algorithm. That's HMAC SHA-256, and then encodes the token. So here I have a payload, and I'm using the standard issued at token, or issued at claim, and it is in the number of seconds since the Unix epoch, 1970, but it's in seconds. In JavaScript, date.now returns milliseconds. So we convert that into seconds. Here we have a secret that we're going to sign it with, and here I'm just going to log this out. So that was the payload. It was just a timestamp, and this is the token. And if I rerun this, notice the payload only changes a little bit at the end because that's just the timestamp changing, but the signature changes drastically. This thing is very hard to guess, that's the secure property. That's what makes JSON web tokens secure, because whenever you change the payload, it changes the signature. One thing to note, so I mentioned we were using the HS256. There are two different kinds of algorithms you can use with JSON web tokens. Symmetric algorithms, where you use the same secret for signing and verifying. That you want to make sure your secret stays secret. Don't send it on Slack, don't send it on Discord or email. That needs to stay secret. Because if someone has that token, they can sign tokens on behalf of you. Asymmetric algorithms are a little bit more complicated. You need to create a public-private key pair, and you sign with the private key, and that's the thing you keep secret, but you can verify the token with the public key anywhere. So you'd want to use that if you want people to be able to verify that it came from you without you giving them your secret. JOTs can be attacked by accidentally pasting a production token on your slide deck. Don't do that. And that's for any tokens, not just JOTs. So there is in the JOT spec a none algorithm, which means it doesn't use any signature. They are pretty useless. They don't do it. It's just a JSON object, really. Just happens to conform with the JOT shape. If you notice in here, the 3 parts, there's a missing third part. It's just there. And early versions or the spec allows for none, and if your library allows you to verify none without disallowing it, that's an attack vector, because they can put whatever they want. If you have any authorization information in the token, they can just put whatever they want, make themselves an admin. This one's a little bit more complicated, but along the same ideas, where the attacker gets to choose the algorithm that gets used. Because JOTs are self-describing, they can put whatever algorithm they want. So this specific attack can happen if you are using asymmetric keys. You sign with your private and you verify with your public. But here, the attacker has access to the public key because you gave access to everyone. And they sign a new JOT as if it were using the HS, the symmetric key algorithm. And so here I'm going to demonstrate this. Here I'm using a library, JSON web token. This is an old version. This has since been patched away. But here, run this code. So just walking through what this code does. First thing it does is it takes a user ID, says the role is member, something we can use to grant authorization. Log that out, and now the attacker has that token that's in their browser or whatever, and they have the public key. So that's all they have, the token and the public key. And now they're going to sign a new JOT, and they're going to change the role to admin and add in their own property there, hacked true, to prove that they were the master. And they're going to sign it with the public key, but change the algorithm to HS256. So here, we're using asymmetric key algorithm. We're using the algorithm ES256. And they're going to sign it with HS256. So they have the payload. They generated a new token, which is definitely different. This one ends in CYQ_XC. And now that token is going to be sent back, and it's going to verify with the public key, just like they should. And it validated. It was successfully hacked. Now again, this is an old version of the library. This has since been patched. But you do want to, if you're using JOTs, you want to make sure and test the libraries you're using, because of the self-describing nature, you have to check your libraries. All right, so what can JOTs be used for? Temporary download URLs, similar to what you use with S3 if you've used S3 uploads. Callback URLs, let's say you call into a service, you don't know how long it's going to take, so you give them a way to call back to you. You sign a JOT, and they send the JOT back to you. Like we mentioned at the beginning, tokens are URL safe, so you can just put it in the URL. You don't need to URL encode it or anything like that. Inter-service state transfer, so let's say you have a proxy service, and you have a bunch of microservices behind it, and you don't want every single microservice to make a call to your auth service. You can sign a token that contains the user information for temporary use for the duration of that request, and they don't have to hit the user service. OAuth 2, some places or some OAuth 2 implementations use JOTs for their access tokens. It's not required. There is a part of the OpenID spec, which is an extension of OAuth 2, which does use JOTs when they send information about the user. Likely, in most cases, when you're using JOTs, libraries will take care of the details, but it's important to know about some of those vulnerabilities we've talked about. Short-lived auth tokens. So this is one where I am a little shaky on. I think there's more used ways of creating auth tokens than JOTs that are more secure. You really only need it if you need to scale horizontally, like you have a real database read problem or something like that. But making sure that those are short-lived are important, because once the JOT is out there, it's not revocable. People have the token and it just expires when you told it to expire. All right, session tokens. So before we get into how to use session tokens, I want to talk about how sessions are sort of normally done, I guess. Session tokens are usually, they're just an ID, and it's a cookie, and it's usually signed similar to how a JOT is signed. They're HTTP-only cookies. You usually need some kind of backing store. That ID only references something in the database, and you need to go fetch that information from the database, whether it's Redis or Mongo. If you don't have a backing database, every time your server restarts, everyone logs out because that session data is gone. But when you deal with cookies, you also have to deal with CSRF. Or if you don't care about old browsers, then all you need is the same site cookie. But it's just a lot of overhead you have to deal with. And so some people use JOTs instead of these session IDs. So a stateless JOT is one where you encode the session information directly in the JOT. You don't lose the session on restarts. You've built an expiration. You just put whatever you want in there. You don't need to call back to the database. There's also stateful JOTs that are basically just session tokens, because you just encode an ID and you reference the ID. You're still looking stuff up in the database. So I wanted to talk a little bit about an implementation of that. Okay, I've got a simple API here of like 5 endpoints where you can create a session, so you can log in, gives you back a token, and then use that token as an authorization header. And I may need to lean over here so I can type. Okay. Hopefully that's secure. Okay. So I have 2 users. I have an admin user and just a normal user who doesn't have access to a whole lot. I'm going to log in as the admin user. I get my token. Just put that in a variable up here so I can use it. And now I can do things like list all the users, and I can update users. And let's just say for a second, like, oh, this user's, they need to be an admin. So I'm going to take that ID, and I'm going to update the user. I'm going to change their role to admin. Okay, that was successful. Now I'm going to log in as that user. User password, both passwords. And I get a token for that other user. And that other user, because they're an admin, they can also list all the users. Okay, so let's say admin said, oh, admin, oh, I didn't change it to the user token. Let's just make sure this still works. Okay, user can do everything because they're an admin. But we're going to change it back. Admin decides they have too much power and must be destroyed. And we're going to change it back to a normal user. So now they shouldn't have the same access. So they've updated it back to that role. Signing in back as that user. And I shouldn't be able to list all the users. Oh, they didn't, because that token, or that they were able to access it because the token included that whole user. Sorry, if we're looking here at this, when you log in, we can just encode the whole user in there. So that's a problem. Well, to keep up-to-date information, rather than just pulling the user off of the JOT, we probably need to fetch stuff from the database. So if we have the user, then we're going to do API dot get user by ID, rec.auth.user.id, .then user, rec.user is user, next. So now it should be up to date now. So now I do that. All right, so I still had to go to the database, so we didn't get all the benefits there. So now if I send the request, they don't have access to that endpoint anymore. Okay, so now let's say I want to log out. If we notice here, the logout isn't really implemented, and it's kind of hard because we don't have a record of the session, so you can't really delete it per se. But there is a way we could do it. We could add another thing in the database of like revoked tokens. And this library that consumes the JOTs, there's a is revoked function that we could check. Rec token revoked tokens dot push. Now hold on, wait a minute. What were these benefits again? No need for session store. Well, now we do, because now we have to keep track of the revoked tokens. And we have to call the database again to keep up to date information. It kind of looks like we re-implemented sessions the normal way. Okay, don't use JOTs for session tokens. There may be good reasons to do this. Come talk to me afterward. I'd love to talk about it. For the most part, sessions are not good for JSON Web Tokens. Okay, JOTs have very, very limited use case of short-lived things. Session tokens are not a good use case. There are too many things you have to re-implement. There's also just a cryptographic minefield you have to navigate. So, best practices. Don't use the none algorithm. Make sure that your libraries don't accept that. Verify the tokens always. There's many libraries let you just decode the token. You need to make sure you always verify it. Don't put personal information or secret information in tokens. Use standard claims when possible, when applicable. Asymmetric keys, there are some algorithms that are stronger than others, especially in the ES 25 or 256, 384, 512. There's some elliptical curve vulnerabilities if you choose bad keys. You can encode, in the header, you can encode a key ID to make sure on your back end you select the right key to verify with, so you don't end up with the key confusion attack vulnerability. Including issued at, if for nothing else, makes the cryptographic key change, gives it enough entropy to change. But really, if you're not prepared to dive in to that cryptographic minefield, maybe look for alternatives. Speaking of alternatives, there are alternatives to JOTs. Pasito is one that I've been looking really closely at. It takes a lot of the choice out of like choosing which algorithm to use. There's really only, you choose public tokens that people can view stuff, and then encrypted tokens. And the algorithm choice is baked into the spec. Bronca I don't know a whole lot about, other than it's also a newer standard. And Biscuit is another type of token that lets you sign new tokens based off of the token you have that has the same or fewer privileges. And that's my talk. Thank you.